In today's video, I'm going to show you how you can turn your manual equatorial or AltAz mount into a fully motorized go-to one for very cheap. Now this process might seem a little bit difficult or tricky, so I'm gonna keep it as simple as possible for you. So let's move on to the parts. For the parts we will need a D1 R32 main controller board, a CNC V3 shield, two-stepper driver, the LV8729, one micro USB cable like this one, a screwdriver, a multimeter, two stepper motors, and a 12-volt power adapter. So let's move on to the next step. First you have to download this OnStep file from the description link. It is a Google Drive file, so just download. Once you download, you will receive this OnStep folder over here. Just open it up and you will see these files over here. These are 5 files. So what we will do first is you have to install this software over here, this Arduino IDE 2.3.3. Just install this software. Now once you have installed the software, go to this folder OnStep, open it up, scroll down a bit and select this OnStep file, this one. Just double click it and it will open in the software we had just downloaded it right now. Now once the software is opened in this Arduino software, is we are gonna select this tab, the file tab, and go down and click on preferences. Now once you have clicked preferences, we are gonna paste a link over here. To get the link, go back to the files we just downloaded and open this file, this one, links. Now once the links file is opened, copy this first link over here. Just copy this ESP32 link, go back to the software and paste it over here by right clicking and clicking on paste. Click on OK. Now once you have pasted, go to tools, go to board and click on board manager over here. You shall see this boards manager column appear on the left side. Click on filter your search and type ESP32. Now once you have typed ESP32, there are two options to install. The first one is Arduino ESP32 boards. We will skip this one. And the second one is ESP32 by Espressif. We have to install this one. So click on drop down menu, scroll a bit and click on 1.0.4 and click on install. It will start installing the drivers for our main controller board. We did not install other version because those does not work with this project. So make sure to select 1.0.4 version. Now this might take a while depending on your internet speed. Now once the drivers are installed, it will say platform ESP32 1.0.4 installed. Now this is all the code for our project. Select the config tab over here. As you can see, this config tab selected, and here we will change some things. In this off, as you can see, it is written pin map and the value is off. Just change this off to CNC3 like this. Just cut the off and write CNC3 over the off. Now scroll down a bit and you shall see this define serial C board default, this line over here. So just select the off from here, from the serial C board default, and type here on like this. In the serial C board default, type on. Scroll down until you see this axis 1 RA is at M. This is the axis. Now what you have to do is find this axis 1 driver model, change this off to LV8729 like this, LV8729. Now once you scroll a bit more, there is written axis 1 driver micro steps. It is also off. Change it to 128. 128 axis 1 driver micro step. Scroll down more and here is similar thing, but this is axis 2. Everything will be again same as the upper one. Type LV8729 in the axis 2 driver model, and then underneath it axis 2 driver micro steps, change it to 128 like this. Okay, so now we will upload the code to our main controller board. To upload the code, there is this drop down menu. Click on this arrow icon over here. Click on select other board and port. Type here ESP32 space DEV developer module. Now you have to select this one, ESP32 developer module. Select it, and here you have to select the port of the main controller board where it is connected. So to find out which port will be connected, take the main controller board and the micro USB wire which I mentioned. Now you have to connect this wire like this. Connect it in the micro USB port of the main controller board like this. Take the other end of the wire and plug it in any one of your USB ports like this. As you can see, a blue light has turned on our main controller board like this. So how we will find which port? As you can see, there is COM4 serial port now labeled. You might have several of these like COM1, COM2, COM3, COM4 like these. You might have several of these listed here. To find out which port is your main controller board connected to, what you have to do, just disconnect it again like this, and as you can see the COM4 just disappeared automatically. Now if I again connect it to the to our port, COM4 appears again. So the one that disappears and reappears is the one we will select. This is COM4 just selected. Now once we have found out which port is our main controller board connected to, just click on OK, and now we will click on this one, this upload button. Click on this and it will start to compile our main code. which means it is finding if there are any mistakes in the code. This will take a while, so just wait. Now once the sketch has been compiled, it will start to upload the code to our main controller board. As you can see, the progress is mentioned here, and as you can see, it is uploading the code, and now it has mentioned that it has done uploading. Now what we will do is we are gonna click this serial monitor. Click over here. Once you have clicked, in the, as you can see, this is the output, and this serial monitor will appear here. What you have to write here is colon gv colon gvp and hash, like this, colon gvp hash, and just hit enter, and it should say OnStep, which means the board is working correctly. So now the code has been uploaded. Just disconnect your main board and we shall start the assembly process now. To start our assembly process, we will need the CNCV3 shield. So first we're gonna remove a resistor from here. It is written R1. Just remove this resistor. As you can see in this picture, this resistor, you have to remove this resistor from here. Either you can cut it with scissor or pliers, or you can just desolder it like I did from here. I desoldered it because I will use that resistor in another project. I just desoldered the resistor from here, so don't forget to desolder the resistor. After desoldering the resistor, we are gonna jump some pins, which means we are gonna connect the pins. As you can see, it is written M0 column, M1 column and M2 column. We are gonna jump these in this pattern. We're gonna jump the y-axis also. M0 column like this, M1 column like this, and M2 column like this. In this picture, you are seeing that you are seeing the pattern in blue lines. This is the pattern in which we will connect. Now to connect these wires or these pins in vertical, you can use these jumpers. These jumpers are really cheap. You can use these jumpers to connect these pins together. As you can see, these connect in this vertical axis like this. Either you can use these jumpers, or you can just solder these pins like this, like I did. As you can see, I soldered them vertically. Also over here I soldered them vertically. So if you don't have a soldering iron, you can just jump these pins by using these jumpers. As you can see, I have not connected this one because I used a jumper over here, as I have to show both the methods to you. So we will need our LV8729 driver, and underneath the driver there is written enable over here, or it might be written only en over here. This, because this is the en pin, it is showing that this pin over here is the enable pin. So we will take this enable pin and join it on the enable pin over here on the CNCV3 shield. As you can see, it is written en over here, which means this pin is the enable pin. So just align the en pin and fix the driver like this. En pin on the driver and the en pin on the CNCV3 shield. Just connect this driver. It should easily be put down. Just push it like this, and as you can see, this is the wrong pattern. The EN pin is over here and the EN is over here. Just put the second driver like this and make sure to align the EN pin on the V3 shield and the EN pin on the driver. Now once you have aligned the EN pin, we're gonna take our main controller board and just fix the CNC V3 shield over it like this. Just push it down and it should go like this. You can align these borders to make sure these are connected together correctly. Now we will power up the board. To power up the board, you are seeing there are two connectors, this black one and this blue one. This black one is to power up the main controller board and this blue one is to power up this red CNC V3 shield and the motors. Now you can use two 12-volt adapters to power these, but I know many won't do that, so there's a cheaper way to do it. The cheaper way to do is take the pin of our 12-volt adapter and cut it like this and join the both wires again till these wires are outside near the pin, and just put the positive one over here, negative one over here, and tighten these nuts. The second method to power this board is way easier for the one who have soldering iron and soldering wires. What I have done is I have soldered a negative wire over here, a positive over here. Now I can just take this positive wire and fix it here, take this negative wire and fix it over here, as you can see, just like this, and take our 12-volt pin. Now if I connect it over here and turn on the power socket, the board is light up and there is no need for two adapters. Now is the tricky part. We are gonna set the current in these two drivers. Now to set the current, make sure the device is powered on and make sure there is a blue LED light, and also make sure there are no loose connections over here, and take our multimeter and you should receive two wires like these with this potentiometer, sorry, not the potentiometer, with this multimeter. Take the black one and fix it in COM, this one over here. Take the red one and fix it in the V ohm milliampere, V ohm MA. Fix it over here. Now change this to DC volt 20. We are gonna measure our current. We will need a value. To find out the value, divide the ampere of your motor by 2. Now in my case, my motor has 1.5 ampere, so 1.5 divided by 2 will be 0.75, so I have to set 0.75 in this driver. To do this, take the negative one and fix it over here in the negative one. Take the positive one and fix it in the first driver, this potentiometer over here. Now as you can see, it is right now supplying close to what I need, 0.75, and it is 0.70. So what I'm gonna do, I'm gonna turn this screw really slow and again check. As you can see, the value has decreased, which means I have to turn it in the other direction to which I was just turning. Check it again. Now it has increased a little more, and as you can see, it is close to our required value. Now plus minus 1 plus minus 0.03 won't affect the motor, so if it is really close to your required value, so don't change it, it shall work okay. Now take the red pin and attach it to the second driver, this plus pin on your driver, and as you can see, it is right now supplying 0.50. I will again try to reach our required value, which is 0.75. As you can see, it is really close to our required value, like this. So just turn off your multimeter. Now unplug the main controller board. Now we will put on our motors. To do the wiring, as you can see, there are these two pins, X and Y axis. There are four pins on the X axis and there are four pins on the Y axis. So we will connect our motors to those pins. Now as you can see, on the same CNC V3 sheet, the X axis has four pins and Y axis has four pins. So once you have located these pins, you can see, once you have bought the motor also, you will have this type of plug. It might be different for you, like it might be of black color or something like that. So to just connect the motor to the V3 shield, just take the connector and fix it on these four pins, just like this. As you can see, the four pins are connected. Now just like this, connect the other motor also. I have marked 2 points on this gear, so when we operate the motors, you will know that the motors are turning or not. Because if the shaft was only visible and the motors done, you wouldn't notice if the motors are turning. So now just take the 12-volt pin and power it up, and it should give you a blue light like this. Now just take your mobile phone and download this app. This is easily available on the Play Store. This app is called OnStep. On the Play Store, it will be labeled as OnStep Controller 2 by 1Q or something like that. I don't remember the developer. So just open it up. As you can see, this is the interface of the app. Now before we start using our app, we will first go to Bluetooth option and go to rarely used device. There should be a device named as OnStep X or simply OnStep. So just click on it and pair it. As you can see, the pair devices has now appeared. Just go back to the main controller app, and after waiting some time, or just click on three dots connection, click on the pair device on step or simply on step X, click on it and click on accept. Now mine connected instantly, so yours might take us 2 minutes maximum. So just wait like this 2 minutes and it should say on step ready. Yours might take around 1 minute or so. So just wait, and yours might say on step 4.24s or something like that. Now what we will do is gonna click on three dots, go to observing sites and use current location and click on upload. So it has uploaded our current location in the main controller board. Now we will go to initialize spark and click on this set date and time and just click back. Now you can go to tracking and click on start. The tracking has started. Now what we will do, we're gonna select anything from here like solar system, then click on any one of these, Uranus let's say, click on go to, and as you can see the motors have started to turn. This means that it is moving to Uranus. Now what we can do, I'm gonna just abort the operation. As you can see, it has aborted the operation. Now we can just center the object if the object is not directly in the center. So just move it like this. As you can see, it is moving toward west. You can also north. So once like this object is in center, we are gonna just hold on sync and sync here. So this was the project for now. So in the next video I'm gonna teach you how to tune this project according to your mount. So the next video is very crucial if you want to build this on step controller. First you have watched this video and you will want to watch the other video as well. So because the next video is very much important because you want to configure this according to your mount. This was just the testing that the build is working. If you have any other questions, just ask me in the comments. I'll try to solve your problem. And there will be many videos for this project coming in the near future. So tune into the channel and just subscribe or give a like. And that's it for today. I'll see you in the next configuration video.